Hi guys, in today's video we're going to be looking at a simple experiment that you can do that teaches you a little something about the water cycle and about solids, liquids and gases. I'm going to illustrate the principle of it using a large bowl, a cup, some cling film and some water. However, usually what you will need is slightly more space, and actually instead of having a bowl, you try and dig quite a large hole or a pit. So if you have the facility to do that, if you have grounds where it's okay for you to dig up a portion of it, it's often, you'll get more of a result if you have a bigger surface area for this. But I'll illustrate the principle here in a classroom setting just to try and explain what's going on. So what we've got here, we've got a bowl and we're going to fill it with water. Okay, now I say fill it, I'm just going to put a bit of water in it. So what this represents is maybe water in streams, in oceans, that sort of thing there. Okay, so this is just water in the environment. This is going to represent land of some sort. So we'll say that this is the sea, and here's our island in the middle of the sea. Now, in order to get it to stay stably in there, it will often help to actually weigh it down a little bit, because I don't want it floating loose in the middle. But I would actually weigh it down, maybe put some glue tack in it. But you get the idea just now. We do need it to stay in the same place here. Okay, so we would actually try and tack it down. So imagine that's tacked down in the middle there. That's going to represent land, dry land. Now, what's going to happen over time, especially if we put this in direct sunlight, is water from the oceans is going to evaporate. Now, the nice thing is we could actually simulate this even more accurately and make this perhaps salty water, perhaps even dirty water. You can contaminate this water, and it actually makes for an even more striking illustration of how this works. So we've got our water in here. We're going to place it in a sunny position and we're going to cover it. Now, I find it works better if you cover it with a darker material, maybe a bin bag or something like that. But at the moment I'm just covering it with cling film, and it needs to be airtight, so I would actually put an elastic band around this to hold it in place. Obviously the cup would be inside directly under this. Now what happens here is the heat from the sunlight is going to cause the water to evaporate. But then when it hits the cling film or the plastic sheeting, whatever you're using, it's going to condense on that. Now, whenever it condenses, it's going to run to the lowest point. It's going to run to the lowest point on that. Now, the lowest point might be anywhere, but what we're going to do is we're going to make it so that the lowest point is bang smack in the middle, and we're actually going to do that by weighing it down slightly. I'll just use a candle there. So what happens is when the water condenses, it then tracks to the lowest point, at which point it's going to drip conveniently into our cup, which would be positioned underneath. So what we'll have is water evaporating, condensing, and then precipitating into the cup. So 3 of the stages of the water cycle: evaporation, condensation, precipitation, all happening within one small scale demonstration. So the cool thing about this is, in principle, you should end up with pure water inside the cup. So you could have contaminated water in the still itself. This is referred to as a solar still. You can have contaminated water within the still, but within the cup, you'll end up with clean water. This is actually widely used as a survival strategy. They put solar stills on survival rafts so that people lost at sea can purify seawater. It's also a widely taught survival strategy for desert survival, and you can use almost any wet materials. It doesn't have to be water that's in here, contaminated or not. You can use just wet materials, leaves and any other sources of moisture that you might be able to gather that might not be drinkable. You can then purify it using a solar still. But like I said, it works better if you're able to do it in a large pit rather than this. But you will get some results, and you'll get a little bit of water collecting in the cup, even on a small scale example, as long as you have enough heat to do it. Give it a shot. Cheers.